Good evening, all of you. My name is M. Likith Kumar, second year B.Tech in Information Technology. And now I want to discuss with you about the programs and the common and program speeches. Let's break down some of the key concepts and their characteristics. 1. Factorial recursive solutions. Factorial is often demonstrated using recursion, where a function calls itself to calculate the factorial of smaller numbers, iterative methods. Factorial can also be calculated iteratively using loops, which can be more efficient for large numbers too. Prime numbers divisible only by 1 and itself. This is the fundamental definition of a prime number efficient primality tests. There are various algorithms like the sieve of Eratosthenes and Miller-Bean test to efficiently determine if a number is prime 3. Palindrome reads the same forward and backward. This is the core characteristic of a palindrome applicable to both strings and numbers. String manipulation palindrome checks often involve manipulating strings or numbers to compare them in reverse order. 4. Armstrong number sum of digits raised to their power equals the number. This is the defining property of an Armstrong number, also known as a narcissistic number digit extraction. Calculating an Armstrong number requires extracting individual digits from the number and performing operations on them. 5. Fibonacci series generates numbers based on previous terms. Each number in the Fibonacci sequence is the sum of the two preceding ones. Golden ratio. The Fibonacci sequence is closely related to the golden ratio, a mathematical constant found in nature. 6. Bubble sort iterative comparison of adjacent elements. Bubble sort repeatedly swaps adjacent elements if they are in the wrong order. Basic sorting algorithm. It's a simple sorting algorithm, but not very efficient for large datasets. 7. Binary search divide and conquer approach. Binary search efficiently finds a target value in a sorted array by repeatedly dividing the search interval in half. Requires sorted input. Binary search only works on sorted data. 8. Linear search sequentially searches for an element. Linear search checks each element in the array one by one until the target is found. Works on unsorted data. It can be used on both sorted and unsorted arrays. 9. Leap year check divisible by 4, not divisible by 100 unless divisible by 400. This is the rule to determine if a year is a leap year. Greatest common divisor, GCD, Euclid's algorithm. A classic and efficient algorithm for finding the GCD of two numbers. 11. LCM calculation least common multiple. The LCM is the smallest number that is a multiple of both given numbers. GCD-based formula. The LCM can be calculated using the GCD of the two numbers. 12. Matrix multiplication nested loops. Matrix multiplication involves nested loops to iterate over rows and columns. Computational complexity. Matrix multiplication has a time complexity of O(n)(3) for general matrices. As graph traversal. BFS explores a graph level by level, visiting all nodes at a given depth before moving to the next depth. Queue-based. BFS uses a queue data structure to keep track of the nodes to be visited. 15. Depth-first search DFS graph representation. DFS explores a graph by going as deep as possible along each branch before backtracking. Stack-based. DFS is often implemented using a stack to keep track of the nodes to be visited. This information should provide a good overview of the concepts and features presented in the table. And I hope all of you understood about the topic, and thanks for watching.